Hello YouTube, this is your friendly homework help tutor, Joanna. I had a question recently about how do you determine whether a radical is real or where a radical is defined. So let's think about the most simple or a very simple radical of the square root of x. So if we have the square root of x, where this function is defined in real numbers is where what is under the radical is positive or 0. So when you have a negative under an even radical, or like a negative under a square root, that means that the function is not defined in that region. So in order to show where a function is defined, we need to find where it's not negative. So not negative means that what is under the radical, for this case, what's under the radical is just x. So to show that it's not negative means that it's either greater than 0 or equal to 0. So we set what's under the radical greater than or equal to 0. So in this case, this function is defined where x is greater than or equal to 0 because only x is under the radical. To show you a little bit of a little different example, say we have the square root of x minus 4. So for this case, what's under our square root is x minus 4. So we set what is under the radical, which in this case is x minus 4. We set that greater than or equal to 0, because again, we need what's under the radical to not be negative. So where is it not negative? It's not negative when it's greater than or equal to 0. So to find the values of x in which that is true, we solve for x, so add 4 on both sides. And we get, this side cancels out, we get x is greater than or equal to 4. So this would be one example of a square root. Also think about if you have a cube root. So say we have the cube root of x. This rule for needing what's under the radical to be not negative is only the case for even radicals. So this is a square root. So a square root is an understood radical of 2. This is a radical of degree 3, or cube root, which means our radical is odd. So when our radical is odd, x can be anything. It's not limited to not being negative. It's okay for a cube root to be negative. And that's because a cube root means you're finding 3 things that multiply together to give you whatever you have under your radical. So say we have the cube root of negative 8. We can find that if we multiply negative 2 times negative 2, times negative 2, I drew a square root, negative 2. Negative 2 times negative 2 is a positive 4, and then times another negative 2 is negative 8. So that means the cube root of negative 8 is a negative 2, because we can write that as the cube root of negative 2 cubed, and then the cube root cancels out with the cube, and it leaves us just with negative 2. So it's okay to have a cube root of a negative, but if you have a square root of a negative, let's think about if you have the square root of negative 4. Let's try the square root of negative 4. What are 2 things? Since it's a square root, we need just 2 things to multiply together to get what's under the radical. If we have negative 2 times negative 2, that would give us a positive 4. There's no way that we can multiply 2 things together to get a negative, because if you multiply 2 negatives together, you get a positive. So that's why it's not defined to have a negative under the radical for even radicals. But it's okay to have a negative under a radical for an odd radical. So that's the general idea. you set what is under, if you have an even radical, just to give you a kind of a general formula, if you have an even radical, which means you have a root where n is an even number, let's say we have something under the radical, then we set what's under the radical greater than or equal to 0, and we solve for our value of our x. But if we have an odd radical, so we have an nth root, so this is where an n is an even, and this is where n is odd, then x has no restrictions for an odd radical. At least not in terms of it needing to be either negative or positive. If there was a rational equation in there, then you would have to deal with it as a rational as well. But just thinking about it in terms of the rules for radicals. So there you go. I hope that's helpful. Feel free to leave a comment or a question in the comments, and I will get back to you on walking through your homework question. So take care. Happy studies.